Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. You guys are bad. All right. Today we're going to continue with factoring, guys. We're talking about factoring trinomials in the form of x squared plus bx plus c. Very important because there's another type of trinomial form, which we're going to learn tomorrow, which is where you have ax squared plus bx plus c, where the a is a number that is greater than 1. Okay, so today is a different type. Today we have just x squared. So that means that there is an invisible 1 in front of the x squared. There's an invisible 1 here. There's not going to be a 2 or a 7 or anything in front of that x squared except for that invisible 1. And then there is going to be a value b in front of the x and a constant value c that is by itself. When I'm given a trinomial, I'm going to ask you, or whatever SAT, ACT test is going to ask you to factor it, okay? And before we even actually get into this factoring, let me explain real quick, why. Why do we factor? A lot of times, teachers go ahead and teach the lesson, and there's nothing wrong with what they're doing. Sometimes we don't have enough time to really explain to our students, look, this is the long goal. This is the end result. This is why we're doing it, okay? So real quick, just bear with me. Let's say that you're an engineer, okay? And I know some of you are saying, but I'm not going to be an engineer. I understand. But you're in this class, and this is what you're learning. So let me explain to you why it is that you're learning this. Let me explain to you what professionals do use this. So let's say you're a structural engineer, and you have these two land masses, and there's a body of water here, okay? A river or a lake or a bay, some sort of body of water. And you need to connect these two. You need to build a bridge, okay? If you've noticed, most bridges have an arc like this, correct? Okay. This shape right here, this is called a parabola. And that parabola is derived from what's called a quadratic function. And a quadratic function is derived from an ax squared plus bx plus c equals 0 formula. So what happens is you're going to factor the formula that you figure out here. When you factor it, you're going to have x plus a, and then you're going to have x plus b. You're going to set those equal to 0, and then you're going to set x plus a equal to 0, and this will come later, x plus b equal to 0, and then you set a will equal 0, and then b will equal to 0. Okay, I'm sorry. Yeah, set it equal to 0. And you're going to have these 2 point values here. And those are going to be your x-intercepts. Those are going to be the values that you're going to mark on the land that you're going to actually build on. And this is very important because your computer program is going to make an x and y axis, and these are going to be the ordered pairs where your bases are going to be. This is what's going to tell you how wide that bridge is going to be. This is what's going to allow you to tell you how tall that bridge is going to be. So this is why we're doing what we're doing. Now, I don't expect you to understand what I did here, because we're going to get to this in detail later, but this is why we're doing what we're doing. Okay? So, back to the basics, factoring. So we have this quadratic function, or actually expression, x squared plus 11x plus 18. I want to factor it. So the first thing I'm going to do is I'm going to do a setup. And my setup is I'm going to break up this x squared. I'm going to find the square root of that x squared. And the square root of x squared is x. So I'm going to go ahead and literally set up x and x. Literally. Okay? Step 2, I'm going to ask myself, what times what is the c value, but when added together is the b value? So what number times what other number equals C, but when added together equals B? Yes, sir, my brother. And it'd be 9 and 2. Very good. So 9 times 2 equals 18, and 9 plus 2 equals 11. Now, this step I'm showing you because I'm a teacher, and I'm teaching you what it is that I do in my head. You don't have to technically show me this step. Until you get really good, I would suggest showing yourself this step so you can make sure that it works. But you're going to see that you can do this step in your head. And then from here, give me 1 second, my brother. Let me just close this up, and then I'll answer your questions. And then from here, just plug in the 9 and the 2. X plus 9 and x plus 2. And you're done, literally. Now, back to the example from before. What does this tell me? If I was an engineer and I was calculating how to build this parabola, okay, I would set this equal to 0, and I use something that I'm going to teach you all this later. It's called the zero product property. I would set x plus 9 equal to 0, so x would equal -9 and -2. So what would happen is, on an x and y axis, here's my -9, here's my -2. I know those are going to be my x-intercepts, okay? And those are going to be, my parabola would be going like this. It'd be going upwards like this, okay? And I'm going to show you how and why I know how to do that later. But this is why we factor. This is why we factor. To learn how to graph a quadratic function or a parabola. And next time you guys go outside, look right at the column right outside of our door, and you'll see it's a parabola. And if you notice, they're all exactly the same. They're not exactly the same because someone got lucky. They're exactly the same because they used the quadratic formula, the quadratic function. They factored it. They found the distances, and they copied it over and over and over again. Okay? It's pretty easy, right? So this is really easy if you know how to multiply and add. Very simple if you follow directions. You had a question, though, my brother. You sure? I answered it? Promise? Okay. Thank you, my man. May I continue, gentlemen? Thank you. Okay, now, sign patterns. I added this on to you guys, not to be a jerk or to add extra stuff for you to learn, but read what I put here. Sign patterns. If you memorize the below patterns, it helps you find your factored answers easier. Is this a requirement to know your sign patterns? No. Does it help you? Yes. So it's one of those things like a lot of things in life. It's not required. You're going to get the right answer eventually, probably, but this will make your life a little bit easier, in my opinion. Let me show you what I mean by what is this sign pattern stuff. If I have x squared plus bx plus c, do you see how I have a plus and a plus? Your setup will always be x plus something and x plus something. If I have a plus and a plus, then I have x plus x plus. So my setup is easy. X plus, done. Now you go into what times what is c, but when added together is b, but you know both of them are going to be positive. Simple. When the given trinomial, though, gentlemen, is in the form of x plus bx minus c. Think about that. If you have a negative on the product, but a positive on the sum, that means that one of the numbers was positive and one of the numbers was negative. For example, let's say the product was -2, okay? But the sum was +1. Well, -1 times +2 is -2. But -1 plus 2 is +1, isn't it? So that's why you'd have a positive on the B, but a negative on the C. So when you have a positive on the B and a negative on the C, then you have a x plus x minus. So you know one of them will be positive and one of them will be negative. Again, I don't want you to stress out and be like, oh my God, now I got to memorize these patterns. No, please don't stress out. This should just be a guide to help you out. And you'll see that after you do a bunch of these, you'll start seeing it. And then before you know it, you'll look at this and you'll go, oh, plus minus? Okay, yeah, I got to put a plus minus. Yes, sir, my brother. Correct. Correct. The positive number is going to be larger than the negative number. When the trinomial is in the form of negative negative, x squared minus bx minus c, okay, you're going to have it where it's, again, plus minus. Okay? If I have x squared minus b minus c, I'm going to have, again, plus minus. Let's think of the example I just used before, but let's reverse it. Instead of having a negative 1 and a positive 2, let's have a negative 2 and a positive 1. Negative 2 times positive 1 is negative 2. That means my c would be negative. But negative 2 plus 1 is negative 1. That means my b is negative. So when both my b and my c are both negative, I have an x plus and an x minus once again. And then the last but not least, gentlemen, when I have x squared minus bx plus c, think about it. Doesn't a negative times a negative equal a positive? So this has to be x minus x minus. Is that what you were going to say, my man? Good job. Well done, kid. So if they're all positive, it's x plus x plus. If it's plus b minus c or minus b minus c, it's plus minus. And if it's minus b plus c, it's minus minus. But again, don't rack your brain trying to, oh, this is so important to memorize, Mr. Morrow said. No. This is great to memorize. It's going to make your life easier, but it will come to you if you don't get it immediately right now this second. But hopefully, logically speaking, you can understand how these patterns are easy to find. Okay? Yes, sir, my brother. What do you mean as far as limit to c, my man? Can it be a perfect square? Sure. I'm not getting the question. Go ahead. Can it be any number? Okay, thank you for asking. Okay. C can be any real number. It could be a radical, it could be a decimal. Now, for factoring's sake, it has to be an integer. But we're going to continue this procedure. This goes way beyond factoring. We're going to learn a skill called completing the square. And then we're going to also learn something called the quadratic formula. And when we have the quadratic formula, even if we have the nastiest, ugliest decimal numbers, and even if we got fractions, dude, we can put it into the quadratic formula and we'll find the solution. So to answer your question, C can be any real number. To expand on your question, for factoring's sake, though, they've got to be integers for now. Okay? Thank you, son. Good question. Anything else before we continue, my brothers? All right, so then let's get right to it. Now it's just examples. So let's do it. So we've got a plus plus, so we know it's going to be a plus plus. So my setup, I got an R and an R. Why? Because R squared, I take the square root of that, that's R and R. What times what is 24, but when added together is 11, boys? Positive and positive, so plus 3 plus 8, you're done, literally. That's it. Bye-bye. Have a good day, you're done. Not bad, right? Example 3. It is a minus minus. Very good. Why is it a minus minus? Because you have a plus here and a minus here. Excellent job. Great job, kid. So it's a y minus, y minus. Now, don't let that stress you out, okay? Let's pretend that you didn't remember that it was a minus minus. Go to the original question, though. What times what is positive 8, but when added together is negative 6? Negative 4 and negative 2. So even if you didn't remember it was negative negative, you would have put a negative 4 and a negative 2 here, correct? Does that make sense, guys? That's why I'm saying don't stress too much on, I've got to memorize the sign pattern. No. Learn the procedure. The signs will come. They will flow in naturally. So then what's the point of you even teaching the sign pattern, Moral? That's like a double check. Like, let's say accidentally I put this. You know that's wrong. Because a negative times a positive is not a positive. See what I'm saying? Okay. Next. This is going to be a negative and a negative again. What times what is positive 24, but when added together it's negative 11. That's right, negative 3 and negative 8. Very good, my brother. Excellent, son. Number 5. Again, a negative and a negative. What times what is 2, but when added together is 1. Negative 1. Sir. Well, negative 1 times negative 2 is positive 2, but negative 1 plus negative 2 would not be negative 1. Negative 1 times negative 1 is not positive 2. No, don't say sorry. This is part of the procedure here. Going through practicing, going through test values. Negative 1 times positive 2 is not positive 2. Negative 1 times negative 2 is positive 2, but negative 1 minus 2 is not negative 1. In this case, guys, it'd be prime. I got to throw those in there too. Sometimes nothing works. And I'm glad that you guys went through all of those different suggestions. Good job. Good job. You're going to go through those suggestions sometimes on a quiz or a test. And sometimes you're going to render no answer. Please don't think there's something wrong. Make sure you went through all the possibilities, of course. But if all the possibilities do not render the correct answer, it's prime. Now, there's a problem to that side too, right? Sometimes we as humans, we take the path of least resistance, right? So we see something, we try one combination, we're like, oh, well, it's prime. No, don't do that either. Think about it. Look at all the different possibilities. Then make your decision, gentlemen. How about number 6, guys? It is a plus minus. Very good. What times what is, oh, you guys took it out. Okay, which one's positive, though? Positive 5, negative 3. I'm so proud of you. Fantastic. Because 5 times negative 3 is negative 15, and 5 minus 3 is positive 2. Fantastic. How about number 7? Yes, sir, my brother. I like it. I like the attitude. What you got, my man? It is a plus minus. Very good, sir. Four and 9. No, Papa? 12 and negative 3. Very good. Now look, 4 and 9. First of all, thank you. I'm proud of you for trying. 4 times 9 would have worked for 36. Negative 36. But negative 4 and 9 would have been 5, not 9. Thank you, though. You caught yourself, though. You saw it immediately. You went, oh, no, that isn't going to work. Great job. But then you didn't give up and say, oh, it's prime. No, you stopped, recollected. Wait, there's got to be something else. There are other factors of 36 besides 4 and 9. 12 and 3 was the key. Great job, son. Way to not give up. Sir. It will have a number in front of, x squared will have a number in front of it, and that's tomorrow. But I've got a super easy method for that. Okay? Sir? No, you don't divide it. We're going to use a method, I call it the Cuban method. You'll see. It's nice and easy. Yes, sir. Of course you can, sir. What you got, my man? Correct. Plus, plus. Very good, my brother. Oh, yeah. Very proud of you, son. 30 and 1. Oh, there is a little typo here. There should be an X here. Thank you, son. Appreciate that. Technically speaking, that wouldn't have been possible without that X there. So, but you knew there should have been an X there. That was my bad. No excuses. It's my mistake. Yes, sir, my brother. Correct, sir. The order of the binomial doesn't matter. It could be x plus 30, x plus 1, or it could have been x plus 1, x plus 30. Not at all. Thank you, sir. Commutative property. Okay? But I like that one. That's a good one. This one actually messes up a lot of people, believe it or not. Whenever you're dealing with times 1, it always messes people up. I don't know why. It's just sometimes the easiest is sometimes the most difficult to perceive, right? How about this guy? Positive, negative, positive 5, negative 8 is beautiful. 5 times negative 8 is negative 40. 5 minus 8 is negative 3. Fantastic. Yes, sir, my brother.
Does it matter if like I put x minus 8 and x plus 5?
Again, just like I said before, my brother, you can write x minus 8 here first, and then x plus 5, sir. It does not matter to me, sir. Okay? Well done. Yes, sir. You sure, my man? That's what I'm here for. Okay? How about number 10? Now, good. Now, some of you may be saying, wait a second, Morrow. You just finished telling us that you're going to teach us this tomorrow. You're lying to us. No, I'm not lying. What did I tell you yesterday? Before you do any factoring technique, what do you always want to try to do first? GCF. Very good. Can I take a GCF out of here? 5. Very good, my brothers. So I've got y squared minus 4y minus 35? No, 32. Come on, Morrow. What's wrong with you? Now, please be cognizant of the following. Some of you guys messed up on your quizzes yesterday on this. Drop down the GCF, y'all. Don't forget that. So y and y. So what times what is negative 32? Boy, I think it's negative 4. No. No. Negative 8 and positive 4. You had it almost. I got you. I got you. Takes time, brother. Always check it. What do you mean check? I mean this. Negative 8 times 4 is negative 32. Check. Negative 8 plus 4 is negative 4. Check. The way he had told me before, he had the numbers correct, but the signage was wrong. 8 times negative 4 is negative 32. Check. 8 minus 4 is positive 4. No check. That wouldn't have worked. Always check it. Because you are human, and you mess up. We all mess up. Okay, number 11. Before I get crazy and stress out over that negative 3, what do you think I'm going to do here first? Yes, sir, my brother. Not divide by negative 3. Factor it out. What's the difference, mortal? Well, if I had an equals 0, now I have an equation. Now I can divide negative 3 out to both sides. Now, I swear, I'm not trying to be sarcastic or a jerk. It's a big technicality. There's no equation here, sir. So I cannot divide out a negative 3, but I sure as heck can factor out a negative 3, sir. Like, for sure. And then, what times what is 8, but when added together is 2? No, because 4 and negative 2, 4 times negative 2 is not positive. Exactly. It's not prime either because I factored out a GCF. It's just this, and I cannot go any further. So remember, guys, I can throw some curveballs at you. Be prepared for that. Sir. Yes, sir. GCF always goes outside of the parentheses, just as we learned yesterday. Thank you, my brother. Thank you. God bless you. Yes, sir. Oh, I think I had a question. Sorry. We're good with the lesson, guys. We're done. We're going to practice more, but we're done here. Any other questions before I close out the video? Yes, sir. No, we're good? Promise? Thank you, guys. Great lesson. Have a great day. Thank you.